send and reception of the packets, and at the end there was 0% loss because it was able to locate the device. Here it was able to locate the device and it was able to get the response. And then to also confirm this, when you go back to our switch here and recall the command display MAC address, when you run it, initially it didn't have a MAC address table. But now when you rerun the same command, you'll find that the MAC address table now is existing. It's able to know two devices with this MAC address are connected to port number 1 and port number 2, and they were learned dynamically. Thank you for joining us. In today's session, we'd like to understand a bit of LAN and network configuration. So in computer networks, networking is linking two or more devices. But not just linking, it's also the design. The design of these networks, development of policies to govern the use of networks, and even the integration of different devices in the network. Okay, so the example we'd like to consider in this session is a class C configuration. We may want to have two networks. The first one is network 192.168.1.0, and the other one is network 192.168.2.0. As you know, the default subnet mask for class C is 255.255.255.0. This is because this part, the first three octets, these ones are used to identify the network. We'll do the same on this other side. We'll have subnet mask 255.255.255.0. So the first three octets are used to identify a network. If they're the same, then it means the IP addresses of the devices are in the same network. If they're different, it means they're in different networks. So in this case, you can see this is network 192.168.1, and this other one is 192.168.2. This means these are two different networks because the first three octets are used to identify the different networks. So to learn more, as you can see here, the IP addresses in the range of this network are from network 192.168.1.1 all the way to 192.168.1.255, and then this is the subnet mask. So we have this range of IP addresses. This first one is for network identification. The first IP address here is for network identification, and then this is the subnet mask, and the last one here is for broadcasting. When you're broadcasting to that specific network, we use this. So that means for any given network in class C, whenever you're using the default IP addresses, the first one is reserved and the last one is reserved. The first one is for network identification and the last one is for broadcasting the packets to all devices within this network. So that means the only valid IP addresses in one network are 192.168.1.254. So these are the valid IP addresses. So in total, we normally have 256 IP addresses. IP addresses. However, because of the first one here, the first IP here, which you're using it for network identification, and this one here we're using for broadcast, these two. So the only ones that are valid are these ones. So 256 minus 2, I will have 254 valid IP addresses. So these addresses are the ones we can assign to our computing devices, or the hosts. We call them the hosts. So we don't use this first one because it's used to identify the network, and the last one because we're using it to broadcast. So if a packet has this IP address, the last IP address as the destination IP address, then that packet is broadcasted to all devices in that network. So similarly, we'll need to do the same thing for network 2. We will copy this. So it's from network 2.1 2.254, and then the same thing here we'll have 2.255. The first one is for network identification, and these others are the valid IP addresses. Okay, so now since we have been able to design this network using the default subnet mask, it will still be the same because we haven't done subnetting, where we break down the network into other subnetworks. We're using the default subnet mask. Then we can demonstrate our configuration by using these two networks, network 1 and this network 2. How do we now simulate this? We have the software eNSP. We run this software eNSP. For you to be able to run this application, you need the setup file, eNSP setup file. You also need a VirtualBox software installed. This is how the window looks like. We have the different option up here: new topology, topo, new paper project, open, save options, save as, print, undo, redo. Okay, so familiarize yourself with this. We have an arrow, the pointer, we have a hand to pick and drag components. You can delete a component, you can delete all the lines, you can comment, add some text. Also, you can be able to map out a region by using the drawing palette, which can give you rectangular shapes or even elliptical or oval shapes. You can run, start devices, you can stop devices, you can change how you view interfaces in the topology, and also show the grid or decide to hide the grid. Okay, so we can start by creating a new topology. When you click on new topology, you can see here we can decide to hide the grid or show the grid. And then after you pick the components, you can decide to show the interfaces using this option, show interfaces, or you can decide not to display. Okay, so we like to design that simple network. So if you're going to use this palette, you can decide, let's use this oval and use the fill color, maybe blue for one and then another one. So we'll draw the first and then change the color, let's say to green, and green, okay, and draw the next palette. So assuming these two shapes are just meant to help us map the two networks. So for network 1, for example, we like to pick a device. These are the end devices, PC, PC, multicasting server, client, server. These are the end devices, and then when you come here, we are able to see the routers, different access routers. We also come to this other one, you're able to see the switches. As you know, routers are layer 3 devices. They're able to forward, they're able to route packets from one network to another. And then for switches, they're able to forward packets from a device within the same network to another. So let's start by picking devices. We pick one device here. We have PC1, and then you also bring PC2. Let's hide the grid. We'll have PC1 and PC2. To have these two devices communicate, we'll need a switch. Okay, let's use that 700 switch. We have it here. On the other side, you can also have two devices. You can pick PC3 and PC4. And then as well, we can pick a switch, S700 switch, that allows these devices to communicate. We can add comments. So this is our LAN 1. LAN 1. LAN 1, it will have an IP address 192.168.1.0. Okay, and then on this other side you have LAN 2. LAN 2 will have, instead of 1, it will now be 2 for network 2. LAN 2 and LAN 1. Our intention is to assign these devices IP addresses within this range and should be valid IP address. So for PC1, you can assign 192.168.1.1. This other PC 192.168.1.2. For this other side, because it's network 2, we'll do the same thing. We'll assign 192.168.2.1, first device in that network. Then we'll do the same thing for this one, 192.168.2.2. So we're just mapping, we're designing our network. This will have this IP address, this other one will have this. Okay, so now the next thing is connecting the devices so that we're able to see LAN 1 devices communicating and LAN 2 devices communicating. And to achieve that, we first of all have to start the devices. We power the devices. Power PC2. We also need to power the switch. And so you can see it booting up just like a computing device, because it has an operating system, it has memory, and it can start. So wait, it's fully up now, and we have it here with the default name Huawei. So for us to be able to configure the device, since it's up, the first thing is just do the connection. Connect using the different cables. In this case, we're using the Ethernet LAN cable. We'll use copper. Click on PC1, connect to the port RJ45 port, and then connect to our switch Ethernet 001. Do the same here, 001. Since one has already been used, now you have available port 002. Since we enabled interface displays using this command, that's why you're able to see these labels. And the label display is important to guide us on which interfaces have been connected. You can also see the green markers to show you that the devices are powered and they can communicate. But before they communicate, we still need now to configure the devices. So how do I configure this? Just double click on the PC one, and looking at our configuration, we need to assign the IP address. This is the PC name, the MAC address. We are going to assign IP address manually, statically, and the IP address is 192.168.1.1, and then the subnet mask. Okay, so we'll do that. 192.168.1.1, subnet mask 255.255.255.0. Okay, then we click apply and you're done. When you go to the command tab, type IP configuration, config, you're able to see the configurations have been captured here on PC1. You can close this, you can go to PC2, do the same, but assign IP address .2. So we have 192.168.1.2, and then subnet mask 255.255.255. So you're using the default subnet mask and you're assigning IP address statically. If in case you want to assign the IP address automatically, then you'll need to enable DHCP functionality and also configure the router by assigning it an IP address pool that can be used, that can be assigned to the end devices. So like in the previous case, we go to the command line, IP config, and you're able to see that's been configured. So like in our design, so these two devices are now configured. They can communicate. So going to our switch, we can go to the system view, display MAC address. When you display MAC address table, you can see it's empty. At the moment, there is no MAC address table because these devices are yet to learn that their devices with this IP address configured. And if you want to know that, we can load a Wireshark application by just reading packets in this connection. You right click, capture packets, and it will show you messages being sent and received. So once we try and send some ping messages, you'll be able to see the source and destination. Source and destination IP addresses. So when we go to this device, we know it is 1.1. So we can ping the other device to test connectivity. We use ping command, ping 192.168.1.2. Why? We're doing this because our current device is .1. So we want to test, is it able to send packets and receive packets from PC1. So we use the ping command. When you press enter, you'll notice it's doing that. It's able to send and receive. And at the same time, you can also see here, it's a conversation. At the beginning, when the device is unable to locate where this device is, it does what you call broadcast using address resolution protocol. It's asking, who has this? It's trying to find out, where is this? So when a switch receives an incoming packet and it's not captured in the MAC address table, it does a broadcast to all outgoing ports to try and locate where the device is. So it's a broadcast message. Who is? Okay, then after a short while, there's a response. This IP address is at this. And then now you're able to see successful sending and reply of packets. And you can also see that success from here. You'll notice the first one. You'll notice here send and reception of the packets, and at the end there was 0% loss because it was able to locate the device. Here it was able to locate the device and it was able to get the response. And then to also confirm this, when you go back to our switch here and recall the command display MAC address, when you run it, initially it didn't have a MAC address table. But now when you rerun the same command, you'll find that the MAC address table now is existing. It's able to know two devices with this MAC address are connected to port number 1 and port number 2, and they were learned dynamically. The switches keep updating their MAC address tables. So switches have what we call MAC address tables and routers have routing tables. That's why a switch can easily just forward packets of data directly from PC1 to PC2. So you don't even need a router to do this. Similarly, you can do the same on the other side. Let's quickly do that. We click on copper wire, connect Ethernet, connect to Ethernet 1, Ethernet, connect to Ethernet 2 port. Move this, remove this one here, remove this one here. And we also start our devices. Start the PC, start the PC4. Then when you come here, assign it the IP address 192.168, but for network 2, so it will be 192.168.2.1. Subnet mask is the default subnet mask 255.255.255.0, and then apply. Okay, we can close. We go to PC4, also assign 192.168.2.2, subnet mask 255.255.255.0, then click on apply. Okay, so when you come to this device, IP config, you can see it's 192.168.2.2. So we can ping PC1 in network 2. Ping 192.168.2.1, and we can see it's able as well to communicate. So the different LANs, the two different LANs, local area networks, are able to communicate. Having devices in each network able to see the other device within the same network. But you cannot see a device in a different network. For example, if you ping 192.168.1.1, which are in network LAN 1 from LAN 2, then there is destination unreachable. And the reason is, first, physically, there is no connection linking these two devices. There's no connection linking these two devices. This one and this one, there's no connection. So to make sure that you have two networks that are able to communicate, we need a different device, a router. Switches are layer 2 devices, but a router here are layer 3 devices, so they can allow us devices to forward packets from one network to another network. So a packet keeps hopping from one network to another. And you can see from here, from these Wireshark messages, these are different packets. And if you understand or remember the parts of a data packet, they're here. For this specific packet, it tells us it's using IP version 4. This is the header length. This is the total length, identification, time to leave, specific details, the source address, destination address of a data packet. It's here specifically for this. If you go to the next one, you'll see the same. But you'll notice they're following each other. This one, request, reply. So we have this reply with 94D4, and then when you come to this other reply, 94D5. So it means they are following each other. Replies that are following each other. So the details of the packet tell us more about the data packet. And because it has all this information, a packet can propagate from the source device to the destination device. So this is how you configure the devices within the separate LANs, LAN 1 and LAN 2. And also remember that we're using private IP addresses. Private IP addresses are issued within a LAN. Private IP addresses are issued within private networks, and public IP addresses are issued by internet service providers. In the next session, we'll be able to test connectivity and communication between two networks. In the next session, we will learn how to ensure that our packets can be transferred from network 1 to network 2. But in such a case, we normally require a layer 3 device, which is a router. So our switch connects to this, and then this other switch connects to the router, and now you can be able to provide a gateway. Our device here doesn't have a gateway. We didn't specify a gateway, so the local router will now be our gateway. Thank you so much. Let's design secure and scalable networks.